Dear students, Assalamu alaikum. I hope you all are fine. Today I am with the second lecture on paracetamol. I am going to discuss today the general method of preparation of paracetamol. That means the reactions by which paracetamol is prepared. So dear students, let's begin. We know the molecular formula of paracetamol is this, that is N4-hydroxyphenyl acetamide or N4-hydroxyphenyl ethanamide. Now let's write the name of this compound. N4-hydroxyphenyl ethanamide or N4-hydroxyphenyl acetamide. This compound, this paracetamol is prepared from this compound, that is phenol. Its another name is hydroxybenzene. Single word, hydroxybenzene. Here hydroxyl group is a kind of substituent, that's why its name is hydroxybenzene. And this reaction, this change is done through several steps. Now we will see the steps one by one. The first step is preparation of nitrobenzene, that is, this is nitrobenzene and this is nitrobenzene. So nitrobenzene is prepared from phenol. This is the compound phenol, where hydroxyl group is present. That is a kind of electron donating group towards the benzene ring. That means benzene ring activating group. When it donates electrons towards benzene ring, then ortho positions and para position become electronically rich. This is number 1 point. Number 2 point is aqueous nitric acid produces nitro group as electrophile. So these electrophile will attack the ortho position and para position and compounds will be formed. First of all, this electrophile combines with the para position and orthonitrophenol is formed. And secondly, another nitro group combines with the para carbon and para-nitrophenol is formed, para-nitrophenol. Now the question may arise that how this nitric acid, aqueous nitric acid, is producing nitro group as electrophile. Now let's see. This is nitric acid which is aqueous. Here proton is formed and nitrate ion is formed. At the same time, another reaction happens, that is, this is also nitric acid, HNO3 nitric acid, where the dissociation happens like this. It acts like a base. This is plus, this is plus. Now let's see, this is nitric acid, this is nitric acid. So we can write here nitric acid, and this side we can write H plus OH minus. So this is water, one nitrate ion, and another one is nitro group as electrophile. So this way nitric acid produces electrophile, and this electrophile combines with the ortho position and para position, and we are getting orthonitrophenol and paranitrophenol. Now here we got both the compounds, orthonitrophenol and paranitrophenol. To prepare paracetamol we need orthonitrophenol. That's why from this mixture this paranitrophenol is separated. From the products of orthonitrophenol and paranitrophenol is separated for the next step. At the same time, one point should be kept in our mind, and that is what happens when concentrated nitric acid is used instead of diluted nitric acid. So let's say when phenol is treated with concentrated nitric acid in presence of concentrated sulfuric acid and the mixture is heated, then we get this compound. So what is the name of this compound? We see at carbon 2 one nitro group, 4 another nitro group, and 6 another nitro group. So its name is 2,4,6 trinitrophenol. Trinitrophenol. Its another name is picric acid. Now we will try to know how this reaction is happening. Let's say concentrated nitric acid dissociates this way. Dissociation happens like this, and nitro group, and sulfuric acid dissociates in this way. That is proton plus bisulfate ion. So nitric acid plus sulfuric acid. What we see here, this is water, this is bisulfate ion, and another one is nitro group as electrophile is produced. Since the reagent is very much concentrated, so huge amounts of nitro group is produced, and as a result at the same time ortho and para positions are attacked by this electrophile, and that is why we get this compound 2,4,6 trinitrophenol. And another point we should know, that is here the byproducts are water and sulfuric acid. Again, how these products are forming, that is bisulfate ion which is produced from this reagent combines with the protons removed from these ortho and para positions. Ortho and para positions which are removed as proton. This proton is added to bisulfate ion and forming sulfuric acid and water. This sulfuric acid is actually acting here as dehydrating agent. So this is the point to be kept in our mind. Next step is step 2, and it is preparation of 4-aminophenol. We got paranitrophenol from step 1. Now this paranitrophenol is treated with tin and HCl. Then nitro group is reduced to amino group in this way, like this. Tin reacts with HCl and produces stannous chloride and nascent hydrogen. this nascent hydrogen reduces this nitro group as amino group, and this oxygen reacts with this hydrogen produced from tin HCl and water is produced. So from step 2 we got 4 aminophenol. This is numbered as 1, 2, 3, 4, 5, 6. So at carbon 4 there is a amino group. That's why the name is 4 amino. This is phenol. So now let's write 4 amino phenol. So from step 2 we got 4 amino phenol. Step 3 is preparation of paracetamol. That is final step. From step 2 we got 4 amino phenol, and in step 3 from 4 amino phenol we will get paracetamol, that is N4-hydroxyphenyl acetamide. And when 4 aminophenol is treated with acetyl chloride or acetic anhydride, then this one hydrogen of amino group is replaced by acetyl group, and the final product paracetamol is obtained. How this reaction happens? Let's see the simple mechanism. If it is acetyl chloride, then CH3COCl, this portion replaces this hydrogen here, and this chlorine combines with a hydrogen and form HCl. If it is acetic anhydride, then acetic anhydride is CO and again CH3. So here this is one portion and this is another portion. This portion replaces this hydrogen. If we use acetic anhydride, this portion replaces this hydrogen and paracetamol is formed, and another portion combines with this hydrogen which is removed here, and then this one, that is CH3COOH, CH3COOH, that is acetic acid is formed. So this is the way by which we can produce paracetamol. Another way by which paracetamol is prepared, and this is Hochst-Celan's pharmaceutical company method. Here phenol is treated with acetic anhydride. In short, it is acetic anhydride, and in presence of hydrogen fluoride as catalyst, then we get acetylated phenol. The name of this group is acetyl group, and this acetyl group is introduced to the benzene ring. That's why it is called acetylated phenol. When this acetylated phenol is treated with hydroxylamine, this is hydroxyl group, this is amino group. So now it is hydroxylamine. When this compound is treated with hydroxylamine, then a compound is obtained which is called ketoxime. Now this ketoxime is treated with sulfuryl chloride in presence of trifluoroacetic acid. Then rearrangement happens, and after the rearrangement we get our desired product, that is paracetamol or N4-hydroxyphenyl acetamide. So dear students, this is all about preparation of paracetamol from phenol. No more. Thank you very much.